Let's start by solving few problems. Look at the first one. Integral cos square x from 0 to pi by 2. Alright, so when you have 0 to pi by 2, we'll use one of the properties. The question, the heading clearly says using properties, right? So first what we'll do, let's call this as I. 0 to pi by 2 cos square x dx. Now apply f of a minus x property. So I is equal to integral 0 to pi by 2 cos square of pi by 2 minus x, which is give us 0 to pi by 2 sine square x. Correct? Add the two values. So that means you'll have 2i is equal to integral from 0 to pi by 2. What is cos square x plus sine square x? 1, right? Dx. Just dx, right? So then what do we have? So you'll get 2i is equal to x from 0 to pi by 2, right? So 2i is equal to pi by 2. So I is equal to pi by 4. So the answer for the first question is pi by 4. Very, very simple. Alright. Similarly, let's do the second one. Okay. See the second one. Again, start by taking I. I is equal to integral 0 to pi by 2 root of sine x. Guys, directly write it down. Root of sine of pi by 2 minus x. Root of sine of pi by 2 minus x plus root of cos of pi by 2 minus x. Isn't it? This is going to become root of cos x by root cos x plus root sin x from 0 to pi by 2. This is the integral. Now take this I and add it with the question because question is also equal to I. So LHS is going to become 2I 0 to pi by 2 root of sin x plus root of cos x by root of sin x plus this dx. Everything cancels out. So you will have 1 just like the previous one what we just did, correct? So what do you have? 2I is equal to integral from 0 to pi by 2 1 dx. Guys, if you integrate, you will get 2I is equal to pi by 2 or I is equal to pi by 4. So the final answer for the second one is pi by 4. Very, very simple. Correct? Let's do the third one. Third one, don't you think it's very similar to the third one? Sorry, the second one. So since it's very, very similar to the second one, actually the answer is the same. Answer is for that one is also pi by 4. Okay, so let's do the third one now. See the third one. Apply the property, all right? Same property of whatever we have been doing for the last two problems. So you are going to get I is equal to integral 0 to pi by 2. Guys, if you directly write it, that is sine to the power of 3 by 2x. And if you apply the property, the limit property, okay, then you are going to get cos power 3 by 2 into x, correct? Divided by cos power 3 by 2 into x plus sine to the power of 3 by 2, correct? Add both of the equations. That means you are going to add the question I with respect to the I what we have now, correct? So when you add 2I is equal to, so cos to the power of 3 by 2 plus sine to the power of 3 by 2. Divided by cos to the power of 3 by 2x plus sin to the power of 3 by 2x dx cancels out 1. So we have 2y 0 to pi by 2 dx. So 2i is pi by 2. So I is equal to pi by 4. Just like the last two questions what you had, this is also the same type of question. Not the same question, same type of question. Clear? So now let's move on to the fourth one. See the fourth question. Guys, don't you think it's very similar to the first three? Take pi by 2 minus x. Do the same thing. Do add both of them. So your final answer for the fourth question. The fourth one is going to be same as the last one, which is pi by 4. Clear? The fourth one is the same as what we did for the third one and the second one and the first one. All the first three, actually the first four are one in the same type of problem. Clear? Now let's do the fifth one. See the fifth question. Do you remember one of the examples which I showed you? That modulus type of question. This is exactly the same. Now since you have x minus 5, anything less than 5 is negative, anything more than 5 is positive, isn't it? So we split the limit. That means you have I is equal to integral from 2 to 5 minus of x minus 5, 5 to 8, just x minus 5. Let's integrate. Because when you integrate, you can apply the limit, you will get the answer. Fine. So when you do this, this is going to be minus of x square by 2 minus 5x. This is from 2 to 5 plus x square divided by 2 minus 5x from 5 to 8, correct? So minus of 25 by 2 minus 5 by 2, this is the first part, minus 5 into 5 minus 2. See, this is for the first part, that is minus of x minus 5 part. The next one plus, you get 64 divided by 2 minus 25 by 2 minus 5 times 8 minus 5. Now all the limits have been substituted, correct? So in this case, what you're going to get is minus of, so guys, there is a small change here. This is not 5, this is supposed to be 4. Okay, 2 square is 4. Now what do we do? So we are going to take, so guys, multiply the minus sign. Minus 25 by 2 plus 4 by 2 is 2 plus 5 into 3 plus 64 by 2 minus 25 by 2 minus 5 into 3. Correct? So plus 5 into 3 minus 5 into 3 cancels out. Then the rest of it you can't do anything. You have to multiply and simplify. Alright? What do you get now? See this minus 25 by 2 minus 25 by 2. That's minus 50 by 2 plus 2 plus 32. So minus 25 plus 32 plus 2. Correct? Now 32 minus 25, which gives you 7. 7 plus 2, so 9. So the answer for the fifth one is going to be 9. Fair enough? Now let's do the sixth one now. See the sixth one. So here we are going to use that a minus x form. Okay. Look at this one. So you have I is equal to integral 0 to 1 x into 1 minus x whole power n. Now this you can also write it as integral 1 minus x 1 minus of 1 minus x, which is just x. Correct? Now what we do is, see, multiply this value in the sense I is equal to 0 to 1. See, when you multiply, you'll get x to the power of n minus x power n plus 1. Isn't it? Very, very simple. Now split and integrate, so much more easier to do. So I is equal to integral 0 to 1 x power n, 0 to 1 x power n plus 1. Right? So this is going to be, so here you can say I is equal to x power n plus 1 by n plus 1 from 0 to 1, of course, minus x to the power of n plus 2 by n plus 2 from 0 to 1. Apply the limit. If you do, I is equal to 1 by n plus 1. 0 anyway it cancels out. Minus 1 by n plus 2. Take LCM. N plus 1 into n plus 2. So n plus 2 minus of n plus 1. Isn't it? So the final answer will be 1 by n plus 1 into n plus 2. So this is going to be the final answer for the sixth one. Understood? So remember which property we are using. Okay. Now let's move on to the next one. That is the seventh one. Let's continue from the previous one. See the seventh question. See what you have. 0 to pi by 2, 2 log sin x minus log of sin 2x. Right? So first what we do now is 0 to pi by 2. Remember this is I value. Always this is I value. 2 log of sin x minus this expand sin 2x. That is log of 2 sin x into cos x. Right? So I is equal to 0 to pi by 2, 2 log sin x minus of, if you all remember the laws of logarithm, we can write this as log 2 plus log of sin x, so log of sin x plus log of cos x. Correct? So this will be integral from 0 to pi by 2, 2 log sin x minus log 2 minus log of sin x minus log of cos x. This is I. Now 2 log sin x minus log sin x, right? We are going to have I is equal to integral 0 to pi by 2, 2 log sin x minus this is going to be log of sin x minus log of cos x minus log 2. Correct? So this is what we have as the final answer of I. And now, before you integrate, let's apply one of the laws of the, not laws, more like property of the definite integral. That is a minus x. Remember, f of x is f of a minus x. We are going to apply that for this one. Alright. So if you apply that, what you're going to get is I is equal to 0 to pi by 2 log of sine of pi by 2 minus x, which is cos x, log of cos x minus log of sin x minus log 2, right? Now what do? We add these two equations. So LHS is going to become 2i 0 to pi by 2. See, when you add both of them, look at the terms. Log of sin x cancels. Log of cos x and log of cos x cancels, correct? Remember when you add both of them. So now what do you get? You're going to get minus log 2 minus log 2, correct? That's minus 2 times of log 2. Now all of these are all numbers, these are all constants, right? So 2i is equal to minus 2 log 2 integral 0 to pi by 2 dx. 2 and 2 cancels, right? So what do you have now? I is equal to minus log 2 into x from 0 to pi by 2. once you integrate. So I is equal to minus pi by 2 log 2. So the final answer is going to be this, which is minus pi by 2 log 2. Very simple, very direct. Understood? Now, moving on, we are going to do the eighth one now. See the eighth one? See, for the eighth one, again, we are going to use 0 to pi. Use that a minus x. F of x is equal to f of a minus x formula. So what we have is I is equal to 0 to pi x dx by 1 plus sin x. So I is equal to 0 to pi minus x by 1 plus sin x. Remember, sine of pi minus x is sin x, isn't it? Now, add both the equations, the first one and the second one. So, when you add, 2i is equal to 0 to pi minus x plus x, which is basically pi by 1 plus x, correct? Now, why 1 by 1 plus x can be solved in multiple ways. Fair enough? Now, one of the ways what you can do is multiply the numerator and denominator by 1 minus sin x. That means what you have is 2i is equal to 0 to pi 1 minus sin x divided by, so pi is anyway outside, pi is constant, 1 plus sin x into 1 minus sin x, which is 1 minus sin square x. Correct? So 2i is equal to pi 0 to pi 1 minus sin x by cos square x. Individually divide. So 2i is equal to pi 0 to pi 1 by cos square minus sin x by cos square x, which is secant square, and then the next one is going to become tan x into secant x, correct? So what do you have here? You have 2i is equal to pi into integral of secant square x minus integral of secant x into tan x from 0 to pi. Fair enough? Now, integral of secant square x is what? Tan x. And integral of secant x into tan x is what? Secant x. Correct? So, then we apply this and we apply the limit. Alright? 2i is equal to pi into tan x from 0 to pi minus secant x from 0 to pi. Isn't it? So, I is equal to pi by 2 into tan pi minus tan 0. Next, minus of secant pi minus secant 0. So, pi by 2 into 0 minus 0 minus of secant pi is minus 1 minus 1. Correct? So, you have pi by 2 into minus of minus 2, which is 2. Therefore, I value is how much? I value is going to be pi, just pi. No change whatsoever. Clear? So the value or the answer for the eighth question is going to be just pi. Fair enough? Let's move on to the next question. Ninth question. See, for the ninth one, again use f of x as f of a minus x. That is, I is equal to integral 0 to pi by 2 sin x minus cos x 1 plus sin x into cos x. Correct? Now apply that particular formula. So we are going to have I is equal to 0 to pi by 2 cos x minus sin x by 1 plus cos x into sin x. Next, what do? We take these two, we add both the equations. Okay, we add. See, when you add 2i is 0 to pi by 2. See, when you add, the denominator is one and the same, correct? Look at the numerator, what you're going to have. Denominator is 1 plus sin x into cos x. Numerator, sin x minus cos x plus cos x minus sin x. So sin x cancels, cos x cancels. Don't you think we are going to get 0? That means 2i is equal to 0. That means I value is how much? I value is going to be 0. Very, very simple problem. I is equal to 0. Understood? So the numerator gets cancelled. That is why the entire integral value is going to be 0. Fair enough? Now let's do the next question. All right. The 10th question. See the 10th one. I is equal to integral 0 to a root x by root x plus root of a minus x. Now after that, what do? So again, take it as 0 to a root of a minus x by root of a minus x plus root x. So what we just did is, wherever you have x, you put a minus x, correct? So even here also, if you put a minus x, the a and a gets cancelled, so you're gonna get this one, isn't it? Now what do? Add both the equations. That means you get 2i is equal to integral 0 to a root x plus root of a minus x by denominator is one and the same, correct? It's just that it's a plus b, one more it's b plus a, so it makes no difference. So root x plus root of a minus x. Cancel off. What do we have now? 2i is integral 0 to a dx, just dx, isn't it? We get 2i is equal to integral, it's going to be x from 0 to a. So 2i is equal to a. So what do we get as the final answer? We get I is equal to a by 2. So this is the answer for the 10th question. Clear? So this is the answer for the 10th one. Now moving on, we'll do the 11th one. Solve the 11th one. See, the major part of this 11th question is that you need to know what limits are we going to take. That is, which function is negative, which function is positive, and what limits. This is very, very important. Fair enough? Now, see, the easiest way to understand whether the function is going to be negative or positive is by applying the limit itself. All right. Now, take x value as 0. Okay, within the modulus sign, take x value as 0. Now, if you don't have the modulus sign, then if you have x minus 1 and if you put 0 in the sense, what I'm taking the lower limit. Lower limit is x is equal to 0. Now substitute that in the function f of x, which is x minus 1. What do you get? F of 0 minus 1. It's negative. Correct? Now put x is equal to 1. So f of 1 will be 0. That means 0 to 1 in that limit, my function f of x is negative. Anything more than 1, my function is going to give me a positive value. Correct? So what we are going to do now is that we split the integral to get we are going to take the integral within that particular limit. That is, I is equal to integral from 0 to 1 minus of x minus 1. Correct? That's what we were doing till now. Plus 1 to 4 x minus 1. Fair enough? So this is going to be minus of x square by 2 minus x from 0 to 1 plus x square by 2 minus x from 1 to 4. If you know this, you will be able to answer. Okay, so let's do it here. It's very easy. So minus of 1 by 2, correct? Minus 1. 1 by 2 minus 1 plus the next one is going to be 4 square by 2. 4 square is 16 by 2 is 8 plus 8 minus 1 by 2, the upper limit, minus of 4 minus 1 is 3. Correct? The first one is going to be half plus 5 minus half, 4 and half, which is 9 by 2. Understood? So 1 by 2 plus 9 by 2 is 5. So the answer for the 11th one is going to be 5. Fair enough? So this is how you do the 11th one. Now let's move on to the next question, that is the 12th one. Sine square x is that. That's a function. I is equal to integral minus pi by 4 to pi by 4 sine square x. Now sine square is an even function, isn't it? So the value is not going to become 0. But what you can do is you can apply one of the properties. That is 2 times 0 to pi by 4, if you remember. So the same thing can also be written as 2 times 0 to pi by 4 sine square x dx. This is applying the last one, 8th property, right? Now, sine square x you need to integrate. You have to write in terms of cos 2x formula. That is, I is equal to 2 times 0 to pi by 2, 1 minus cos 2x divided by 2. 2 and 2 cancels, which becomes integral 0 to pi by 2, 1 minus cos 2x dx. Correct? So, I will be equal to x minus sine 2x divided by 2, 0 to pi by 2, 0 to pi by 2. Correct? So, this is going to become pi by 2, the first part, minus 1 by 2 into sine of 2 into pi by 2 minus sine 0. Correct? See, 2 and 2 cancels out. What is sine pi? 0. What is sine 0? 0. So, this entire term is going to become 0. Correct? So, half into 0 is anyway 0. So, what do we get? Therefore, I value is equal to pi by 2. So, the final answer is going to be pi by 2. Clear? So, the answer whatever we have got is with for the 12th one. And this is using the last property. So, whatever the problems you have seen in the last two videos, that is this video and the previous video, these are certain types of problems what you can expect. And also, these are the type of problems what we have solved using only the properties of definite integral. Fair enough? Now, this is the last set of problems what we have done. And later on, you're going to see what are the things you have learned in this particular chapter called integrals.